Blobsky, is that you?
Yes, it is me, QF. I have something very, very important to discuss with you.
What is it? It's literally 7 o'clock. My schoolwork starts at 7:30. Did you find out my purpose, perhaps?
After all these years, at last I have.
Okay, cool. Where can we meet up?
I'm actually at your front door right now. Hurry.
Okay, hold on. I'll be right there.
Yes, you're here now. Come on in.
Where are we going?
We're going to the algebra section for this. Also, before we arrive there, we have to discuss the square roots. They're very essential to who you are.
Okay then. I want to recap. I've forgotten most of my knowledge about square roots.
Okay, so square roots can be split into the product of two square roots because of this property. This property states that the square root of xy is equal to the square root of x times the square root of y. So for example, we can split the square root of 80 into the square root of 5 times 16. And split that into the root of 5 times the root of 16. We can simply root 16 into 4. So the square root of 80 is 4 times the square root of 5.
Pretty cool. For bigger numbers, I would use a calculator though.
Yes, that is advisable.
Did you figure out what this symbol means?
Well, yes, it means that you both add and subtract to get two different results.
Is that all I need to know? I mean, I am pretty complex. This can't all be explained in a few minutes, right? I have to attend class in about half an hour.
Well, yeah, I can only teach you the basics for now.
Okay, sure thing. Yes, we're here. I'm excited.
Whew. Now it's time to start learning.
Okay, I'll let you do the talking.
So first of all, I've got my friends A, B, C, and X here to demonstrate. So this is a recreation of the terms and operations you are made out of. And I discovered that you are related to the quadratic equations. However, the quadratic equation needs to be equal to 0 for this to work. If we try to isolate x on the quadratic equation, ax squared plus bx plus c, then you get, well, u. You're just a sort of specialized equation that solves for x on any quadratic equation. So I found out that when you replace the coefficients of the quadratic equation from earlier, you can plug it in the quadratic formula to get the roots of the equation.
Whoa, that's so cool.
I know, so let's solve a simple quadratic equation. 4x squared minus 7x plus 3. If you plug in the coefficients of the equation to the formula, 4 being a, b being negative 7, and c being the last coefficient, 3. You can solve it with the formula to get its roots.
Ooh, are you gonna make me solve this one?
I'll let you solve this yourself, QF.
I'll go solve the square root first. So, negative 7 to the power of 2 minus 4 multiplied by the quantity 4 times 3, that's positive 1. 2 times 4 is 8. So, negative of negative 7 or 7 plus 1 is 8 and 7 minus 1 is 6. So this means that the roots of the equation are 6 over 8 and 8 over 8, which is 1. Cool, I love this.
Yes, you've already gotten the hang of it. So now we're going to have a more unique problem. We'll use the equation 2x squared plus 12x plus 8 to demonstrate this.
Okay. So we're assuming that all of these quadratic equations are equal to 0, right?
Yep.
So for the root, 12 to the power of 2 minus 4 multiplied by 2 and 8 is 80. And the root of that is 4 times the square root of 5.
Yes, you're correct. This means that the equation has two or more real number solutions due to it not resulting to a negative number.
Ooh, what is that about?
Well, there's also this thing called discriminants, which determine if the equation has two solutions, one solution, or no real number solution at all. So the discriminant is the expression within the square root of the formula, which is b squared minus 4ac. If the result of that expression is positive, then the equation has two solutions. If it's 0, then it only has one solution, 0. And if it's negative, then the equation has no real number solutions.
Oh, okay. I get it.
Yes, you really learned so fast, QF.
So, I'm assuming you've got more problems for me to solve?
Yeah, I do. I've got two of them to be exact. Wait. No, I left them at the graphing section.
Oh no, we gotta go there now.
I remember I left it somewhere. Yes, it's here.
Phew, Well, getting out of this section and back to the algebra one will be a hassle. So let's stay here.
Yeah, sure thing. So I have more complex problems over here. But first, let's finish solving the problem I gave earlier.
Okay, I think I figured it out. The problem has two solutions. The answers are -3 plus the square root of 5 and -3 minus the square root of 5. 2 times 2 is 4, and -12 plus 4 times the square root of 5 over 4 is -3 plus the square root of 5, while 12 minus 4 the square root of 5 over 4 is -3 minus the square root of 5. Is that right?
Yup. Here's another one for you. 3x squared minus 8x plus 13.
First, solve the discriminant, which results in -220. However, the discriminant is negative, so there are no real number solutions.
Perfect. I've got one last problem up my sleeve. -9x squared plus 9x plus 18.
I got it. Okay, I think I figured it out. The answers are -1 and 2. Solve the discriminant, which results in 729. 2 times -9 is -18, and -9 plus 27 over 18 is exactly -1. While -9 minus 27 over -18 is exactly 2. Yes, I did it. And with 5 minutes to spare.
Haha, yes QF, you can go now. Just know that there are a bunch of other factoring methods, which are better used in some equations like graphing, factoring, and square roots. The quadratic formula is useful, but it shouldn't be used all the time.
Okay, goodbye Bobski. I learned a lot from you today. I'm so happy to finally know my purpose.
Bye!